This is Britt Caswell with another example video. In today's video, I'm covering example 1 from lesson 5-1 in the SavvasRealize Algebra 2 textbook. In today's video, we are looking at finding all real nth roots. So I just want to explain a little bit of vocabulary and what it means to be an nth root. Okay, so when we are talking about an nth root, we're talking about using this radical symbol, right? And we have what's called an index of n. And the number inside is called the radicand. Okay? So when we describe an nth root, we are wondering what number raised to the nth power will get you that number inside the radical. Okay, so that's kind of what we're trying to do, but in reverse. So with Savvas, what they do is they start us out, I'm going to try to make this bigger for those of you guys in the video, is they start us out with a question. It says, what are all the real cube roots of 125? So what they're actually asking us, they're saying a cube root, which is the third power here, of 125. So we're wondering what value can be cubed or raised to the third power to equal 125. So I think it's interesting here because they expect you to know that 5 cubed is 125. So I just want to show you a little trick. What I actually do is I find what's called the prime factorization of 125. So I'm going to break it down into like a factor tree, for example. I know that 125 ends in 5, and if I divide that out I get 25, and 25 is 5 times 5. So don't be ashamed to go back to your roots and get that prime factorization. So what I'm doing is I'm using the cube root of 5 times 5 times 5. And if you have 3 of a kind, because that's what matches our index, you could pull that outside of the radical, and that's where the 5's coming from. Alright, now understand the situation, and it has to do with the degree of what we're dealing with. So we're looking at the exponent. If you have an odd degree, you're going to have an odd number of real roots. So here I had a degree 3. That means that I'm going to have either 1, 3, 5, 7 number of answers here. So here I had one answer, which was 5. So I had an odd number of roots. Now if I have an even degree, so if this had been like something squared, the square root, I would have an even number of real roots. This means that I usually have a positive and a negative answer. So just look out if you're looking for like fourth roots or something like that to make sure that there's even and odd. I'm sorry, positive and negative. So let's check this one out. So it says, what are all the fourth roots of 16? It's kind of weird that they spell it out to us, so let's write it out in math terms. So a fourth root means that my index is a 4 of 16. So it's asking what number times itself 4 times makes 16. So what I'm going to do is I'm going to do a little factor tree for 16. Okay, 16 is 4 times 4, neither of which is prime, and 4 is 2 times 2. So 16 is 2 times itself 4 times. And so because that index is 4, I need 4 of a kind to pull the 2 out of the radical. So I have 4 2's, so this is 2. Now, remember how we were talking about even and odd? So here I have an even degree, right? Because I have the fourth here for my index. That means I also need a -2. Because if I had 16 as -4 times -4, for example, or I'm sorry, if I had 16 here, I could look at it as 4 times 4, but can't this also be like -2 times -2 to make 4? And -2 times -2 to make 4? So that's where that negative is coming in, because a negative times a negative makes a positive, which then turned positive up here. So because I had an even index, it gave me both a positive and a negative possibility. So just be aware of that. That's going to come out here. Let's try another one. So this one says the fourth roots, so 4 for my index, of 81. Now recall, 81 is 9 times 9, and 9 is 3 times 3. So I have the fourth root of 3 times itself 4 times. So because I need 4 of a kind to pull it out of the radical, I get a 3. Now remember, these could be -3's, right? Because -3 times -3 makes a positive 9. So I could also put a negative here. Alright, now let's try this last one with the cube root of 64. So when we talk about a cube root, it's what number raised to the third power equals 64. Now when I think of 64, I think of 8 times 8. And 8 is 4 times 2. And 4 is 2 times 2. So here I have the cube root of 2 times 2 times 2 times 2 times 2 times 2. Now you could recognize this, by the way, at this level. See how I have a 2 and a 2, that makes 4. And then I'd have 3 4s. So you don't have to go all the way to the prime level if you can recognize that 64 is 4 cubed. Just so you know. But here we are. So I did my prime factorization. And I'm looking for 3 of a kind. So here's a set of 3 of them. And here's a set of 3 of them. So what I'm pulling outside of my radical is a 2 and a 2, which is 4. And so now we have to think about whether it could be positive or negative. Like, what if we had a -4 to the third? Okay, so if I had a -4 to the third, that would be a positive 16 times -4, which would be a -64. So -4 didn't work. And we know that because of the odd power here. We know that 4 is the only one that works. So there we have it. That is example 1, how to find all the real nth roots. Until next time.